Okay, so let's begin. I think there's a lot of it all together, right? A book is at rest on a tabletop. We'll start job with an easy one here. A book is at rest on a tabletop. A free body diagram for this situation would look like that. And I'm going to kind of assume that you all probably got that one pretty much okay. Oh yeah, yeah. I would say, yeah. I would say Fn is perfectly all right. That's what I always use, Fn, and Fw, perfectly all right. Okay? You'll notice here that they did not draw the surface. I would recommend you draw the surface.
I thought it was Ft.
T is for tension. Okay? Remember, the normal force is the force that does what? Yeah, pushes up. It opposes gravity, right? It's the thing that's basically holding it up.
What would happen if nothing held it up? Would it just get like...
It would fall through the table, right? But that doesn't happen. That means there has to be a force.
But wouldn't the table give? Like, it wouldn't just, like, magically go through the table?
Well, it's tough to really say because it's never going to happen, really, right? So, you know. Okay. A girl is suspended motionless from the ceiling by two ropes. A free body diagram for the situation looks like this. Okay, they've got F10s. I would just call it FT myself. I would even call it just T. Okay, good question. And then there's an important difference here. You can't call it a normal force because there's no surface. There's no surface.
You have to draw both of the lines?
You do not have to draw both. I would accept a single one, but remember that these two are smaller, they would add up to this one, right?
Yes.
Okay, so yeah, one is perfectly all right. Although some would argue that it's two separate forces, but I'm pretty flexible. I can touch. Yeah, I can touch my toes. An egg is free falling from a nest in a tree. Neglect air resistance. So all there is gravity. There is no normal force. All there is gravity. It's not on a surface.
Is it falling? Okay.
It's free falling, yes. It's a great song. If there was air resistance, then you would have to draw something like that, yes.
Would it count as like...
It would be friction. Yeah, air resistance is a type of friction, absolutely. A flying squirrel. Flying squirrel is gliding, no wing flaps, from a tree to the ground at constant velocity. Consider air resistance. Because it's constant velocity, the air resistance, F air or FF or whatever you want to label it, it's entirely really up to you in most cases, must be equivalent. So if I were to give you a question like that on a test, what would be the one thing I'd be looking for?
The arrows?
That the arrows would be what?
The same.
The same, right?
It has to be like exactly the same.
Well, within it. I'm not going to get a ruler out, right? But, I mean, if you've got it by more than 3 millimeters difference, I'm going to notice, right? So.
The squirrel flies there will eventually land.
Yeah, we'll eventually land. Now, even if the squirrel is going sideways, you have to show it gauge. Because what do these arrows, are these arrows representing motion?
No,
They're representing
forces.
forces. They are forces. They do not show motion. You can't tell whether that squirrel's going left or right at all. The rightward force is applied to a book in order to move it across a desk with a rightward acceleration. So when you see acceleration, that means there's a net force. Consider friction, neglect air resistance. It would look like that. Now here's a good case, good example where the applied force, it has to be bigger than the friction force. Have they made it blatantly obvious?
Yes.
Well, sorta. I would do that if I was you.
What do the P's stand for? Why don't you just put
Applied. APP. I just use
I
FA.
don't understand why all the letters change all the time. Like,
Yeah.
Is it like FF at the top or FT at the top sometimes? They're not all the same.
Well, it depends on the subscript is what kind of force it is, right? Like if it's a tension, then you put FT. If it's friction, it's okay. Yeah, if you're going to do that one, I would do a nice long applied force that's clearly greater than that. Okay, the next one, I think it's exactly the same situation with one exception. This one is moving at a constant velocity. So in this case here, it's going to have the applied force exactly equal to the friction force, right? And again, I'm not going to get a ruler, but if it's, I might, if you haven't really, please don't make it like 2 millimeters difference and make me guess. Do they know, or is this just one of those, well, I'm going to put it in the middle and then I can argue either way kind of thing? Please don't do that to me. Or yourself. People will do, oh, well, that's close enough. I knew what you meant. Well, then do it right. College student rests a backpack upon his shoulder. The pack is suspended motionless by one strap from one shoulder. So you got tension up, gravity down. And they are balanced because it's not accelerating up or down, right? Doesn't matter if he's carrying it as he walks down the street. Nope. Can I say he? Could be she, doesn't say. Does it?
His shoulder.
Oh, his shoulder, okay. Skydivers descending with a constant velocity, consider air resistance. Constant velocity, right? Balanced. Are you getting these more or less?
So would air react like normal?
Yeah, no, it's not a normal force. Definitely not. There's only normal force when there's a surface. It has to be sitting on the table or on the ground or something like that. It must be a surface. Lucas has a question.
What's the difference? Like, what would we write? Like, we'd write FA for rightward acceleration. What would we write for right? Like being a constant velocity.
You don't put, you mean like something like going back to like this?
Question 6, yeah.
If it's moving at, actually,
It's the same thing.
this is a constant velocity, right? They're equal to each other.
Oh, okay, so the arrows are different. I thought that it was like the notation would be
No.
different.
No, notations are exactly the same, it's just the length. Good question. Good words, notation. A force is applied to the right to drag a sled across loosely packed snow. Remember, that's code for there's friction. And there's a rearward acceleration, so same as before. Are you like, I mean, they're starting to get repetitive, aren't they? Right? There's only so many we can sort of do, especially on a sort of non-rotated, non-angle kind of thing.
So they're basically just trying to drill this into our brain.
Yeah. Although there's one coming up right away, and you might argue. That might even be the next one. I think it is. Is the football the one, the next one?
Yeah.
Should I just show you the answer and let you argue with me? How many people put something like this? Nobody? Well, how come I heard a what? Was it you? No? How come it's just gravity? Because once it's left the guy's foot,
There's no more force applied?
there's no more force applied. Are these arrows representing motion? No, only forces. The arrows represent forces, not motion. And that's the perfect example to check that. Okay? They do not show motion, they only show force. What if it was like the instant that he was kicking? Well then, yeah, you're going to have that force, right? Remember, an object in motion stays in motion. Is there an acceleration in this case? Which direction is the acceleration? I got down, I got up, and I got that way. And Chandler's going like this. Okay, I'll label them. Is it A, down? Is it B, straight up? Or is it C, that way? Which way is the acceleration? Hands up for A. Hands up for B. Hands up for C. Hands up if you didn't put your hand up.
I go B.
Which one are you going for? Who said A? Good for you. Which way is gravity? Is it accelerating? Object in motion stays in motion. It says neglect air resistance. In fact, if you did count air resistance, it wouldn't be that way. It would actually be assuming that it's going up. Is it not going up?
But
Yeah, it's moving upward.
accelerating upwards.
it's only accelerating while there's a net force. After that, once it leaves the guy's foot, the acceleration is down. Remember, these are forces. It's okay. This is how it usually goes. Oh, did I just close the whole thing? The last in number.
I didn't read it was posting.
Okay. In number 11, it says the car is coasting to the right and slowing down. Neglect air resistance. Why is it slowing down if we're neglecting air resistance?
Is the road?
I guess road, like rolling friction. I guess you could say. Yeah.
Oh,
If there was air resistance, I guess all that would happen would be that would be bigger, right? Yeah. So it's coasting. There is no applied force to the right. Okay, good. Now the reason that some of this, like all of this, is important is because when we do problems, you got to be able to identify what forces there are. So give me a second here. We're going to start you off easy, and then we're going to get hard real quick. If you're one of those ones that, I don't need to do this, I'm pretty smart, it's going to take you about halfway through the question before you realize that you should have wrote it down. So I would suggest you write them all down. You have them right there, right? I typed them out for you so you got the question. You don't even have to copy it down. There's only two formulas at the top, and they're really ones you've seen already. You've seen F net equals MA in grade 9, I think. Grade 8? I don't know. And you've seen, now what about this one here? F net equals FA plus FF. Is that a true sort of new formula? Because what does really F net mean?
The net stuff, something that we talked about. I don't
Well,
know. I don't know what it is.
Well, what does the word net mean?
Like the Newtons or something.
Okay, let me ask you a question. When you go work your shift at Tim's or wherever it is you work, right, you get your gross pay and then you get your net pay, which is always, unfortunately, less. So net pay is deductions, right? In fact, you could argue it's the sum of your pay plus all those deductions, which are negative, right? Not so good, right? Your net pay is after you do that. So net force is simply, the applied force is kind of like your gross pay, and the friction force is kind of like one of your deductions. But friction force, like deductions, are always negative. Okay, so I put a plus in there because net force means vector add all the forces with all that direction stuff that you love so much from that unit, right? Remember that? Protractor, angle stuff? Coming back. Mispronounced, you guys. It's supposed to be a cheer. Okay, well, I'll give you an easy one here. A constant force acts on a 12 kilogram mass and changes its velocity from 4 meters per second to 18 meters per second in 3.5 seconds. What is the force? Now, I do this with my grade 9s. I don't care if you do it or not. I know Mr. Friesen was into it big before. If you want to ignore this, you can. I don't think you guys need to do it, but there's probably some of you that could benefit. So I'll start with doing this sort of thing. Okay? There's a lot of you that don't need to do that. Right? But I find the kids that say to me, I don't know what formula to use, benefit from doing this, because now we need a formula that's got M and VI and VF and T in it. And I don't know one. So it's going to have to be probably a 2 or 3 or 4 step problem. We're graduating. Here comes that organization that I've been yelling at you about. T equals 3.5, right? So you kind of got to work mentally backwards. I'm lucky because I can put things down here and then I can drag them over. You can't. And I'm going to yell at you for not going left to right. So think ahead. If you want to write things down starting from the right, you can. What is the force? I need F net equals MA over here on the right. But before do I know the mass? Yeah. Do I know the acceleration? No. I need to know the acceleration. And the only one with acceleration in it is this one here. And do I know T? Yeah. Do I know delta V?
Not yet.
Well, not yet. Not technically. Do you see what I did there? I did all the formulas for you, but I went backwards. Now, after a lot of practice, you'll be able to go, oh, okay, I know what I need to do. I know the path. This is the path you have to take, right? You'll just be able to write that, and then that, and then that, and you just know what to do next. If you're not at that point yet, go backwards. Do it on scrap paper. Use the eraser. So delta V equals VF minus VI, which is the final velocity here. Is it 4 to the 18? Yeah, because it's going from 4 to 18, so there's a little bit of reading involved. 18 minus 4, or 14. Notice how the equal signs line up, or relatively. Now I'm going to take that 14 and I'm going to plug it in over here. Well, I don't need to rewrite the formula. Once is plenty. 14 over 3.5, I think is 4. I don't get too excited about units on those intermediate answers. And then F net is equal to, oh, I keep doing it again. I want to start with the formula. I've been doing it so often. 12 times 4, 48 newtons. How much would something like that be worth? Probably 3. Have you seen 3-step questions like that yet? I don't know if you have. Where would you rate that on a scale of 1 to 10 in the hardness category?
Probably 1.
Probably a 1?
Like 13.
That's a bit of a range. 1 to 13.
I'll say it's
What's
like
a crematorium?
What's a crematorium? It's where they cremate people?
I guess it's burning right now.
Would you?
What do you mean?
Like it's on fire.
What is?
The building.
Oh, like, oh really?
Sneeze?
Well, that's what they do there.
Sneeze?
No, like it's
Oh,
on
it's
fire.
literally on fire. Oh.
Yeah.
Are we good?
When they burn people.
Yeah.
It's on fire.
Oh, that's harmless.
Is it, ask Mr. Elf if that's irony or not.
You want somebody like.
That's irony.
Is that irony?
Somebody, you want somebody like died, they swallowed like a bunch of like bombs, so when they got cremated, it's like, close to crematorium.
Great idea, Lucas. Okay, let's go on to example 2. I'm warning you right off the top. This one's going to be harder. 100 kilogram crate is being pulled in 2 directions with different forces, 250 newtons south and 150 newtons east. If the friction force is 50 newtons, what would the acceleration be? What's your gut tell you about this one? It's the second equation. Well, I'm trying to find the acceleration. Is it going to be A equals delta V over delta T? Is there anything about time in here? No. So the last probably formula is going to be F net equals, and squeeze in that M, F net equals MA. But first step is to find the what? No, that's the last step. What's the first step? Do I know the mass? Yeah. I don't know the F net. When you're asked to find F net, you should always draw what you just learned how to draw, a free body diagram. Now, every one of those free body diagrams that we drew, every single one of them had something in common. They were all what I call sort of a sideways look. Like it's always like looking at something sitting on a desk or something falling in the air. You're always sort of viewing it sideways. But there's another kind of view. There's the bird's eye view, because this one's saying south and east. So you're looking at it from the side, or you're going to look at it from top? From top, bird's eye view, right? Okay, so we got 250 newtons south, and I got 150 newtons east.
So they give you numbers, yeah.
So why didn't we draw for the other one?
Huh? Why don't we draw it for the top one? I don't understand.
Why didn't we draw free body diagram?
Oh, for that first one? Should we have? There's only really one force, right? If there's only one force, then that's the net. So, good point. Okay. Is that all of the forces?
No, there's no.
There's a friction force. Does it say what direction it is? It does not. What do we know about friction? It always
Goes in the opposite direction.
opposite direction. Real good, Lucas. Which direction are these two forces, which I'm going to just label, just for ease of discussion, F1 and F2? Which direction is the overall motion going to be? Southeast-ish, right? Could we come up with some kind of angle, numerical angle? We could, but generally it's southeast, so that means that the friction is northwest. So somewhere up there. Is it important that I get the angle right on that? No, I'm not worried about that. But it is sort of in that direction, right?
Because it's opposite.
Because it's opposite the motion. Which way is the motion going to be? How do you add these two forces? You got to place them. Remember this? Remember how much fun that was? We get to do it again. Okay. How do you add them like that? There's two methods. There was Pythagoras and there was rulers and protractors. What situation is this? This is a Pythagoras. How come?
Right angle triangle.
Right angle triangle. Good. South and east. Okay. So I call this. Can I call this force FA? Is that okay? Like these are two individual applied forces, but I'm going to label them F1 and F2. Can I call this one FA? Is that okay? You think? Yeah. As long as you sort of show me there how you labeling it, I can follow that kind of stuff. Okay, so we got FA squared is equal to 150 squared plus 250 squared. Do I need to do the math here, or can I just give you an answer? Can you do Pythagoras on your calculator without me having to write it all out? So, is there anyone that wants to see it all written out?
The direction.
In the question, Nate. So everyone's good if I just say equals to 291.5? Is everyone okay with that? Do I need the angle right away? It's a force. Forces require direction, especially when it's in two dimensions. Should we do can we do it now? Let's just do it now, before we forget. Tan stuff, remember that? Opposite over adjacent, which one is opposite? 150. Adjacent, 250. Oh, can you believe it? I don't have an angle on my solution page. 30.96? Okay. 31 degrees. We'll round that one. And that would be what? South, and then, remember all this stuff? South, 31 degrees towards the east. What is going on? Okay, but am I even close to done? Not even close. I'm trying to find the acceleration. I'm trying to find F net equals MA. Is 291.5 the F net?
No.
Which one?
Yes.
No.
No.
Yes?
No.
No. Is it F net? No. How come? We haven't dealt with the friction yet. F net is applied force plus friction. Now, do we have to worry about angles and mumbo jumbo here?
No.
No, because I already found the angle. So the applied force is 291.5, and I'm going to add a negative 50, because friction is a good thing because it's always opposite that angle, right? So I don't need to worry about it. I just know that it's negative, or 241.5. Okay? I got 50 from the question. One thing I didn't do is I didn't sort of write out what I know here, right? Although I sort of did. Would you say that this is kind of writing out what you know? Sort of, right? Sort of the same thing. Okay, what's my last step? F net equals MA.
Is that 241?
241.5, yeah. 291.5 minus 50?
Yeah.
Yeah, 241.5. And my mass is a convenient 100. Hopefully you can do that in your head. I get 2.4 meters per second squared. Do I need an angle with that?
No.
Yes, I do. How come? It's a vector. Acceleration is a vector. Are we getting hard yet?
Riley, did you say I give up?
Oh, he's zipping up his binder and he's leaving. He's done. Like, seriously or what? What's going on? Oh, okay. Good luck. How much would that be worth, this whole thing?
5.
8.
Well, one for the angle, right? One for that, one for that, one for that. Would you need a diagram here?
Yeah.
Would you? Do you think you guys could do this without a diagram? I don't think so. Yeah, you're right. I'm looking at 5. I would want to see some sort of diagram. Hey, I should show you the work that the grade 12s are doing to figure out where the little Hot Wheels car is landing.
Yeah, sure, let's do that.
Quick stretch break? Okay, I got 2 more to go. Take a quick stretch break, because the next one's going to be... Oh, jeez.
No, when the teacher says, oh, geez.
I forgot about this one.
Oh.
Yeah, you guys need a stretch break. I'm going to skip to example 4. I'm going to save the real hard one for the end, okay? Is that okay?
No.
Save the ice cream one for that.
Yeah, save
No, let's do the ice cream one. How much room have you got for that?
Quite a lot.
You got lots, eh?
Number 4, no, for number 3, we do that.
Okay, good. Okay. I like this question because it really makes you think. A truck has a mass of 1,800 kilograms. How much force will the engine need to accelerate at 1.75 meters per second squared? The friction force on a paved road is 250 newtons. The reason I like this question is because the people that refuse to write the formula are almost guaranteed to get it wrong. Okay? Because your first instinct, and I'm going to show you here. Let's do the step here. I'm asked to find the, how much force will the engine need? I'm asked to find the FA. I know the acceleration.
Number 3.
I am skipping number 3 up. I know the friction force. I know the mass. Okay? So what is my first step? I know mass and I know acceleration. So backwards from before, my first step is to go F net equals MA. And the mass is 1,800. Notice how I'm lining up the equal signs. 1.75. 3,150.
So that's your
3,150 is the net force. What is your gut telling you to do? Next step.
That's net equals FA.
No, just tell me what to do. Do I add or subtract? Because with friction, you always subtract. And so many of you are saying, oh, well, this is easy. I'm just going to go like this. And I get, what is that? 2,900 newtons.
You'd have to add negative 250 together.
Is that right?
Try a number smaller than a number and get like a higher number.
Huh?
How do you get 2 numbers that are small like that and subtract them and get a higher number?
I didn't. I got 3,000 here. I got.
I didn't see that. I thought that was 350.
This is wrong, my friends. And I guarantee you, some of you that don't write formulas, that's what you wanted to do.
Like 350.
This is what you must do. F net is equal to applied force plus friction force. And when I explain it to you, you will go, oh yeah, that makes sense to me now. What is the net force? 3,150. What is the applied force? Something we need to find. What is the friction force? Minus 250, right? But when you solve that and you isolate it, what happens to the minus 250? Goes to the other side and it becomes plus. And the correct answer is 3,400 newtons. What?
Okay, so, 3,000.
Let's stop and let's think about this. If you need a net force of 3,150 to accelerate at 1.75, that's your net force. That's the force needed after friction has already been subtracted. Right? So you have to add the friction on. It's like doing those net pay questions, right? If you need $3,150 to pay your MasterCard bill, right? Well, you're going to have to earn a little more than that, aren't you? Because you got to pay the deductions. Okay. So as I was saying, you have to push more. The applied force must be more. Does that make sense? Nod. Give me the nod. Do you see how writing the formula will help you here? That's why I do this one. Write the formulas. Okay. Are you ready for example 3? Or are you afraid? Oh, we didn't find A? Yeah, we did. Well, how much force will the engine need to accelerate? 3,400 newtons. Yep. Yeah. Okay. This might be a little bit too hard today. I don't know. Should I leave it for next day? Miss Gray really wants to see it. You guys are pretty focused today. I think I should get a visitor more often. I know it's Friday. Eh? No. You know what? Here's what we're gonna do. We're gonna do half of it today. Can we just do half?
Do it all.